All right, so general reminders. We have Khan Academy due Friday. We're on pace this week. So I know for a couple of the past weeks I've like extended due dates and shifted things around. That will not happen this week because we are on pace. We should finish on time this week. So please try to get that stuff done. If you can't get past it, come to AO or extensions. Reading today, I'll be in a meeting, but I think I'll be available at AO. So remember, you're supposed to like text us is the best way to get on at AO. And extensions, we're just on and ready. Math lab, I also add in a math only time every morning at 8:20. And guys, we're like 1.5 weeks from winter break. So yeah, let's keep at it and make the final push to get to winter break. Any questions before we dive into things? This was the last stuff we wrote down last week. So this is where we're going to start. But does anyone have any like general questions about things? Some of you may have seen that in MAP this morning, I uploaded the Chapter 1 Mastery grades because I finally decided like what to do with those. So please check my message on the Schoology updates, or the same message is in MAP as an explanation for that assignment. Talking about there is now, I might as well show this to you guys. There is now in our Schoology page, so go read that update if you haven't, but in Remote Round 3 folder, there is Chapter 1 Progressing to Mastery, and it's like 6 questions, guys. So you go in here, you complete this, and then, sorry, I should come back here. I didn't know anyone had tried it yet. So it will also be here in your upcoming. If you have a mastery, like when you go check MAP, you don't have to do this. It's optional. But if you want it to go away off of your list of things to do, just go do it. I'm not going to change your grade from a mastery down to a progressing, but there's just some more problems like, of the same content. So stuff that I saw you guys struggle with when we did the test in class, or when you did your revisions, stuff that you were still struggling on, that's the sort of stuff that is on the Progressing to Mastery. Chapter 2 grades, I'll get uploaded either later today or tomorrow, and then Chapter 3 grades, I'll eventually get it uploaded. But yeah, you'll see Chapter 2, I didn't make the due date till January 5th for the revisions, but you should really try to do it soon. I'm probably going to change this potentially to even earlier next week, just so you will come meet with me if you need to. But guys, I'll still help you over winter break if you want. I know a lot of people are like, why would I do math over winter break? But if you are doing math over winter break and you need help, yeah, I'm available. All right, I just sent attendance. Let's dive in. Who can remind us about constant of proportionality? Who can unmute and kind of give us a little summary of what we talked about last time? That's not what I want to do. Anybody? Constant of proportionality? I don't know why my camera is not wanting to start. Sorry, who's that? I can't. This is where Zoom is tough. Say that again. Try to say it louder. Yeah, the constant of proportionality is going to be the unit rate for a situation that is proportional, right? So we said this only is true for proportional relationships. There we go. So guys, your notes should have ended off on something similar to this. Somebody might need to tell me where we ended. Did we get to writing down that k is equal to delta y over delta x? Like, please pull out your notes from last time. Really what I want to know is, did we get all of this written down, and did we draw the graph? If not, we need to. I know Stella takes really good notes, but who else could tell me, do we have this stuff written down? It was at the end of class?
No, we did not.
Okay, so this is what we need to write down. Thank you very much. So last time we just started talking about constant of proportionality, which is also called the unit rate. So guys, pencils out. I'm going to trust you today and not ask to see your graph paper, but guys, I can tell if you're not writing notes, because if you're staring at the computer, you're not looking at your paper, and I can tell you're not writing notes. So please copy this down. These green lines down here in the graph, those are proportional relationship examples. The red line is not, because it does not use the origin point, right? So the red line is an example of a not proportional relationship. So I'm going to scooch this up a little bit, lest somebody tells me that you need it to stay where it is. The last thing...
Need it for 1 more second.
Sorry, so the thing up top just says constant of proportionality. I'm not going to scooch it up very far. The last thing down here, the example, says, like, think about time worked compared to the money that you earn. If you show up and you're like, money please, and you didn't do any work, they're not going to give you any money. If you do some work, then they're going to owe you some money. So maybe like $10 an hour, or like $5 per bag of leaves. So if you need to think about an example of this, let's say I hire Charlie to come rake my leaves, right? Charlie, do you rake leaves? Yes, or are you like anti-leaves? I like the wreath behind you.
If I need to.
If you need to, would you rake leaves for money? If I paid you $5 a bag, do you think that's fair?
Sure. Yes.
Stella's like, yeah, of course, I can do a bag pretty quickly. Now, they got to be full, right? But if I offer to pay you $5 per bag of leaves, and you show up and you're like, all right, Mr. Hudson, I'm here, pay me. I'd be like, dude, you got to rake some leaves. I don't owe you anything yet. So Charlie rakes leaves for a little while. He rakes 3 bags. He comes up and he says, hey, Hudson, what do I get now? And I'm like, well, 3 bags, $5 per bag, $15. Charlie keeps going. He rakes my entire yard. This is not a joke. I had 18 bags of leaves one week when I had to like put out yard waste. If Charlie raked 18 bags of leaves for me, that'd be $90 that I would owe him. So that's an example of like a proportional relationship, saying what I would owe Charlie would depend on how many bags he rakes. Does that make sense? Do we have questions on that example? All right, I'm assuming people are still writing stuff down, because I mean that's what it looks like. Can I scooch up to, is everyone good down to only 4 proportional relationships? Can I scooch past that?
1 more second.
I'm going to pull up a little bit then.
Yeah.
The ways that we're going to see this written, guys, I know I'm starting class by asking you to write a lot, but then there's a lot less writing here in just a couple minutes, so please bear with me. We just got to get some stuff written down so we know what we're talking about. The constant of proportionality will always be the number multiplied by the x, or really the number multiplied by the independent variable. We'll talk about that in a minute. You don't have to write that down right now. But what I have written in green right here, whatever number is multiplied by your x, that's the constant of proportionality. Some websites will call it r. That's what Khan likes to call it, because we're really talking about rates. Some websites like to call it M. That's how I learned it. Like when they taught it to us, they said it's M. Back when I was in college, they were calling it K for the constant of proportionality. Like, you know, if you misspell it and say k, the constant of proportionality. but it doesn't matter what letter they use. If it's multiplied by the x, that's our constant of proportionality. Any questions on anything we've written so far? That's like the main stuff you're going to write today. Yeah, there's not a crazy amount. So guys, the next thing I'm going to do is show you an example and then have you write it. So I'd rather you, like, when I show this to you, like, take a break from writing for a minute while we talk about what we're doing and then write it down. So I'm going to scooch up a tiny bit more and I'm going to change my slide. So don't write this stuff yet necessarily. Like, you do not have to write that yet. So let's say we look at this line, right? I showed you up on our notes a few examples of proportional lines. So these green lines are all examples of proportional relationships. The red line is not. And let's say we're asked to determine what the relationship in that line is. So to figure out that relationship or the rate, we want to put a y value over a corresponding x value. Now, what do I mean by that? When we look at the graph, we can pick points, right? Now, right here would not be as nice because that would be really hard to figure out what the numbers are at that point. But right here where an x and a y line meet each other, that's a lot nicer. So please, the first thing I want you to write down is a reminder that when we talk about points, they're in the order of x, comma, y. X comes first. Then guys, if you just wrote all this green stuff, you don't really have to write y equals r times x again. You can if you want. But what that tells us, please put down what's in the pink box. Our rate, our constant of proportionality, right? This is also, we can say this is also our constant of proportionality. So what we do is we look at our graph and we pick a point, a nice point, right? So this point, if I count out on the x-axis, which guys remember the x-axis is your horizontal axis. So if we count out the x-axis, that takes us 3 on the x. If we count up on the y, like up takes us to the y value, right? Up, down is our y value. That takes us to 2. We come over and double check that. So the math we're going to write down then is our point is 3, 2. That's x, then y. This is where you're going to make your mistake. Because your 3 comes first, you're going to want to put it on top, and that's wrong. This is where people make their mistake. The y value goes on top. The x value goes on bottom, meaning that our constant of proportionality, which we could call r, we could call m, we could call k, whatever you want to call it, is 2/3, resulting in the equation. When Khan Academy asks you for the equation, it's y equals that constant of proportionality times your x. What questions do you guys have? Like I said, we're a little bit behind, so if nobody has any questions, I'm going to move on. But guys, for a couple of you, I can't see your face. I can only see your hair, so please fix that. It's very hard for me to tell if you have questions. And when there's a window behind you, it just looks like you're I don't know, like you're like an angel or something. I hear sleigh bells. Like, I think Mrs. Pettigrew must be listening to Christmas music, so I hear sleigh bells. I'm going to leave my notes up, but encourage you to try for A or B or C if, watch for just a second, and then I'll put my notes back up. If I pick points on A and B for you, there's points that I would pick. Try to write equations for both A and B. Try to write equations of those lines for A and B. I've got the point shown there for you. We're going to do the same thing we did with the last one. Does everyone have what I have written down? All
I
right.
just need one more second.
All right, keep going. I was going to change my next page of notes, but I'll probably leave it. Guys, if I was you, I would set this up. Here, I'm going to show this to you really quickly, and then I'll flip back there. How I have this set up in my notes is line A has point 2, 5. Then I figure out my K, and what I'm covering up is my equation. So I'm going to show this again. But I would write down like line A has a point. We'll figure out what the constant of proportionality is, and then we'll figure out what the equation is. So since line A has 2, 5, it turns into 5 over 2. And they show you that K up on my screen, written in blue. Not my notes, right, but my screen. So, and remember, this is recording. So, guys, if there's any notes where you like don't have enough time to get it written down and need to come back to the video, you can. For line A, since we have 0.2, 5, the slope. Oh, there's another word we haven't talked about yet, really. The slope, or the constant of proportionality. Now I labeled it K just because I felt like it. Is the y over the x, resulting in the equation y equals 5 halves x. Who has questions on that? Line A, our blue line over there. All right, make sure you tried line B on your own. And if, guys, we're going to call this purple line line C. If you want to go ahead and try line C, I think we could use this point right here. But be careful that you check your scale. Every box is 1. Not every tick mark is 1. Every box is 1. So every tick mark is 2. So for the green line, anyone want to volunteer to walk us through it? Talk us through it? Oh, come on, guys. No one wants to be bold? I would. Natalie? You gonna be bold? You gonna walk us through how to do the green line? All right, hit us with it. What should we have written down?
Okay, so 4 is. Hold on, let me look at my paper. 4 is the x and 5 is the y.
Yeah. So I wrote down the point.
Okay, then I put r equals 5 over 4 times
Yeah.
x.
Yeah. Oh, careful. R equals 5 over 4, but the equation we write is y equals 5 over 4ths x. So make sure that you've got that written correctly. R or K or whatever you want to call it is 5/4. Perfect. Good job there. The equation we write uses y and x. What is this point on purple if we use that point? You guys know that if you participate, we would like be done with class sooner, right?
4, 1.
Yeah, it's 4, 1. Ah, sorry, I didn't put that in my slides. So if we use that point at 4, 1, what we would write down is line C has point 4, 1, making our K, guys, this is where you're going to mess up. Our K is not 4 over 1, it's 1 over 4. So K is 1/4 x. assuming we have some time, I plan to do a Desmos activity next week to review this sort of stuff. Try this one on your own. We can call this line D. So if you want, you could write down line D has point. So if you're going to be like me, you could write down line D has point. We pick a point. Careful, now our boxes aren't worth 1. Now every 2 boxes is worth 1. So first thing you want to do is write down what the point is. What's this point?
1, comma.
Yeah, thank you very much. 1, 3. Meaning our slope, or our constant of proportionality. I'm going to start to say slope because it's a shorter word. Our slope is what?
3/1.
Yeah, 3/1, the y over the x. Meaning our equation, bum bum bum, we don't have to put the 3/1, we can just put 3. And now I would like you in your notes to write down the word slope, please. The constant of proportionality is also known as our slope. Meaning how steep our line is. Guys, if you want to play with this, guys, this is one of the things I'm trying to get you to believe me on. Math is meant for play. If you go to desmos.com, right, the website that we use a lot, and I have you come here like to join things or go to your student homepage, if you just click on graphing calculator, you can play with graphing lines. So y equals 3x, like we just graphed, versus a slope of 1, guys. A slope of 1 is our standard slope of up 1 over 1, up 1 over 1. It's like a stair step, right? A slope of 1 is like a stair step. Any number bigger than 1, right? This line has a slope of 3x. Any line with a slope bigger than 1 is going to go faster. Any slope less than 1, like when we saw that slope of 1/4, is going to be less steep. Right? It's going to lay down less steep. So sorry, these colors don't match what we just did over. But if you long hold on here, you can change the color or what the line looks like. So guys, if you want to not right now, I know some of you guys, because you're on computers, you're like, oh, I could go do that right now. Desmos.com, click on graphing calculator, and you can play with stuff, and you can look at how it behaves. The other thing that we could do is we could type it in here, like y equals mx. Check this out. This is super cool. Watch my screen. If I click add slider for m, I can change what m is and look at how the line changes. So like a slope of 10 is really, really steep. What is a slope of 0? Oh, a slope of 0 is a flat line. And negative slopes are going down as we go from left to right. So use Desmos. It's fun to play with math. Do we have any questions with what we've covered so far today? Speak now, or come to AO or extensions or another time to ask me your questions. All right. So continuing on, try this one on your own. This should start to feel more comfortable. We want to get the, what is the slope, what is the equation. Now I'm going to give you another way to write this work. So instead of writing constant of proportionality, which is kind of annoying, let's, if you draw a squiggly line or if you start a new sheet of paper, let's give a label of slope now. Slope is the constant of proportionality. Right? Slope is the constant, S-T-A-N-T, of proportionality. And we can say slope is often referred to as M. Don't necessarily ask me why. Sorry, this is just a triangle. It's the change in y over the change in x. But for now, just for now, sorry, that says for now, we're going to say that's equal to just y over x. We will talk later when things get more complicated about when that changes. But for now, it's just y over x. So for the graphed line that you can see to the left there, give me somebody new. So like not Stella, not Natalie. What's the point that we see on the line? What point do they give us? Yeah, the point is 3, 2. And if we want to put our little reminder, x is first, y is second, meaning our slope is what? 2/3, right? The y over the x. And that means that then our equation for that situation is... Yeah, thank you, Miriam. Y equals 2/3 times the x. Guys, I'm going to throw one more math symbol at you because it's going to make taking notes easier. Has Mr. Cabilo showed you that in science yet? A triangle made with 3 dots?
Does that mean therefore?
Yeah! I'm so glad you guys already know that. So we can start using that in math and say if the point we have is 3, 2, therefore the slope is 2/3, and therefore the equation is y equals 2/3. So remember, that means therefore, and actually I don't think there's an E on the end. I'm not 100% sure. 4, like in golf, has an E on the end, but yeah, I think therefore is just FOR. Try this one. These are different A, B, and C lines. Now, ignore the question for a minute. I want you guys to pick a point. Oh, ew. Ew. Guys, why am I saying ew? If we look at line A and we're asked to pick a point. Yeah, Miriam. Sorry, try to unmute again, Miriam. What was that? I'm having issues hearing you. I don't know if it's me or if... Can anyone hear Miriam?
No, I can't.
Ooh, I had you for a second.
It's in the middle of the box?
Yeah, I can hear you really well now. The line is always like in the middle of the boxes. This doesn't hit, right? That's above that point. Doesn't hit a good point, no good point, no good point, no good point, no... Ooh, this one maybe? Let's just go ahead and say this point way up here. Let's use that point because I think it finally hits a point at the very top. So if we use that as our point, what is that point for A?
2, 10.
Ooh, 2, 10? 3, 10. Yeah, be careful. So guys, on my notes, I'm going to write A. And actually, guys, let's start to try to make your notes a little bit easier. Just put line once, but then we're going to put A, we're going to have B, we're going to have C. So line A has the point 3, 10, we said. Therefore, what's our slope?
And 3.
Yeah, it's the y over the x, so it's 10 over 3. Therefore, our equation is y equals 10/3 x. Do B on your own. I think B is a bit nicer. Actually, I'm just going to minimize this. Might as well leave it. Yeah, B's got some better points. I think I see a point right there. I think I see a point right there. Try B and try C. If you can find a decent point for B and for C, I'm going to color code my notes, and I would suggest if you're able to, you should do the same. So if you have colors, grab that green, grab that purple. What point can we use for B? Who wants to unmute and give it to us? 6, 6 what? 6, 8. Sorry, I thought I heard you say 6, 3. Yeah, 6, 8. Is there another point? Did anyone use a different point?
3, 4.
Yeah, 3, 4. And both of those will work exactly the same. Because whether I use 6, 8 or whether I use 3, 4, I'm going to make a little note beneath it. I could also use 3, 4. We will end up with the reduced fraction of 4/3. Meaning that our equation, be careful, I had stopped writing here. It's not just y equals 4/3, it's y equals 4/3 times x. Questions on line B? All right, do line C if you haven't. I think there's a point here. I think there's a point here. I think there's a point even out here. Who can tell me the numbers that go with those points?
9, 6.
Yeah, 9, 6. So we have 6 over 9. Or if we had used one of our earlier points, it'll reduce, right? So 6 and 9 can both divide by what?
3.
3. So if we divide them both by 3, we get 2/3, which is another point that's on there, right? But the point is y over x. So the point would actually be, is 3, 2? Yeah, 3, 2 is a point that we have. So we could use 9, 6. We could also use 3, 2. Oh, I need to move this over. That's why we can't see. Either way, when we reduce the slope down, we get to 2/3. So y equals 2/3 x. So now let's look at the question that Khan's asking us. What they're asking us is, which line has a constant of proportionality between y and x of 2/3? Guys, this is just a complicated way to ask which one has a constant of proportionality of 2/3. When they say between y and x, what they're meaning is their constant of proportionality is comparing y to x. And what it's actually asking, guys, if you want to understand the constant of proportionality a bit more, the constant of proportionality will take the x, multiply the x by the constant of proportionality, and it will get the y. And that's what we mean when we say y is the constant of proportionality times x, is literally y is a result of multiplying x by the constant of proportionality. So I want you to try this on your own. All this is asking in a fancy way, all that's asking in a fancy way is which line has a slope of 6. So we need 6 over 1. Which line has a slope of 6? or a constant of proportionality of 6. Anyone want to hop in and tell me what you think?
I think it makes an A.
Why do you think that?
Because the only place that it's lined up in the line is 1/6.
Yeah.
To flip that, it's 6 over 1, so that just makes sense.
And remember, we said if we go back to Desmos and compare, any slope bigger than 1 gets steeper. So a slope of 6 is a steeper line. So when we look at the lines that we have A is pretty steep, B is still kind of steep, C is not very steep, right? C is not very steep. So A has the point 1 comma 6, which would become the slope of 6 over 1. Questions? I'm willing to bet money in my wallet that someone's got a question right now. This can't all make sense. I'm not that good of a teacher.
I'm lost.
What do you mean? First off, who said that and what do you mean?
Natalie, and I just am really confused now.
So
not like just this, like what you just said.
Yeah, I don't like how Khan asks these questions. Sorry, my neck kind of hurts. So when they say which line has a constant of proportion, where's my mouse? I don't know if you guys can see my mouse. Which line has a constant of proportionality between y and x? I don't like that they say between y and x. Just chop that out and just say of 6. Which line has a constant of proportionality of 6? And what you want to have on your notes to help you when you encounter this in your homework is that constant of proportionality is slope, right? So that's why I put this on our notes. So I'll write that again. Constant of proportionality is the slope. And we want to remember that a slope of 1 is the perfect stair step. So, guys, if we imagine, and you could draw this on your picture to or draw this on your notes to reference, a slope of 1 is up 1 over 1, 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 or down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. This is the line that we can refer back to and say, well, how does it compare to 1? If it's steeper than 1, like a slope of 6 that we're dealing with here, it is going to be steeper, right? It is going to go up more quickly. So this would be a slope of 6, very steep, goes up to the point 1 comma 6. So that line has an M, a slope, right, of 6 over 1. This line, if I look at this point, it's 5 over 5, which is really 1. And then I could do a line that has less slope, right? Like if I come, I'm just trying to give you guys a few examples before we run out of time today. Sorry, aside from the little bump in my line, that is because my ruler is not. If this is 0.71, the slope of that line is 1 over 7. Right, so if you want to write down a couple examples of different slopes that we encounter. So 1 is the slope that we want to compare back to. And Natalie, I appreciate you saying you don't know, like, that you were confused, because how Khan Academy asks these questions, I disagree with. Now, they probably have a reason that they're asking it like that, but if I was you guys, I would chop out the words between y and x and just ask yourself constant of proportionality of 6. So, this does get easier though. Remember how I said constant of proportionality is whatever numbers multiplied by x? We need to add one more tiny rule to that, is when y is alone. So as long as y is alone, the constant of proportionality in these equation situations should be a lot easier than what we've been doing in the graph. And I know we're just about out of time, so I'm going to fit it in at the bottom of my page here. If the equation you're given is y equals 3 times x, what's the constant of proportionality? Anybody, everybody, unmute and shout it out.
1x.
Wait, what number's in front of the x?
1.
Here? Y equals 3x? 3. Right? So 3, the number multiplied by our x. 3 is our CP, our constant of proportionality, because our constant of proportionality is always the number multiplied by the x. That should be, I had it written in green on my previous page of notes. So in this equation, where y is equal to 5/4 x, what's our constant of proportionality?
5/4.
5/4. And the bottom equation there, y equals 2.5x, what's our constant of proportionality?
2.5.
Yeah, thank you. I don't know why I feel like it's so hard to get people to participate today. It's whatever numbers multiplied by x. So guys, I bet the constant of proportionality from equations assignment will take you like 2 minutes. And I'm not exaggerating. As long as you remember, if y is alone, it's the number multiplied by x, you're good to go. Now, then they start to give you multiple choice. What's the tricky part here when looking for a constant of proportionality of 1/2? What's tricky here? Because I don't see a 1/2 in my answer choices. It's not that easy.
Equivalence.
Yeah, thank you, Isis, and a couple other people jumped in at the same time. We have an equivalent fraction, right? 3/6 is equivalent to 1/2. So another example like that, which of these is equivalent to 3? This is like the last thing we're going to do. Which of these is equivalent to 3? 18 over 6, right? Because if we do 18 divided by 6, that would be equal to 3. Awesome. So thank you guys very much. We had a few more slides that I wanted to cover, but we almost made it through everything I wanted to. So I want to make sure that you guys get a break before your next class. So really, it was just doing more of the problems that were... Actually, this is new content, so let's go ahead and do this problem. Which of these is equal to a constant of proportionality of 0.25?
1/4.
Yeah, 1/4 is equal to 0.25. So that is a perfect stopping point. So when we pick up on Monday, guys, we're going to talk about from tables. So if you're working on your Khan Academy, the tables work, you might need to go watch a video. And I'm in math lab Thursday and probably Friday. So come get help from me if you need to. I might extend the tables assignment to next week, just to be due on like Monday or Tuesday. But go ahead and try to get that stuff done if you can. I want to wrap because it's almost 10:50. So thank you guys very much. You are all amazing. I appreciate you coming to class and giving me your focus. Have a wonderful rest of your week.
Bye.
Bye, guys.
Bye, Strauss.